My name is Anna, and today we're going to be solving this equation. In order to solve this, we first find the whole. In order to find it, we need to factor both the denominator and the numerator. In this case, it will be x minus 2 and x plus 3. And in the denominator, it will be x minus 2 and x plus 2. We then cancel both of them, and we are left with this equation. Dx will be the number that gives you 0 in this. So it will be x plus 2. Then this is your x. In order to find the y, you need to exchange the 2 for the x in this equation. And the answer will be 5/4. And that will be your whole. Then to find the x-intercept, we will be using this simplified equation. We need to make this numerator equal to 0. So this will be our x-intercept. Then to find the y-intercept, we will be substituting the x's for zeros. Then the answer will be 3/2. And that's your y-intercept.
So, hello, my name is Marco, and I'm going to show you how to take the vertical asymptote, the horizontal asymptote, and how to graph it. So, let's take out the vertical asymptote first. And for taking the vertical asymptote, you have to find a number that, if replaced in x, gives you, in the denominator, 0. So, here our number will be -2. Plus -2 plus 2 gives you 0. So our vertical asymptote will be -2. Now let's find the horizontal asymptote. So we know that 3 basic rules for finding the horizontal asymptote exist. The first one is that if the exponent in the x in the numerator is greater, there will be no horizontal asymptote. If the exponent in the x in the denominator is greater, it will be y equals 0. But if, like in this case, we have the same exponents in both numerator and denominator, you have to divide the number that is in front of x. For example, here we have an imaginary 1 and 1, because we know that if you have a 1 in front of x, you don't write it. So 1/1 will be 1. So that will be our horizontal asymptote. So now let's graph our equation. The first thing we have to plot in our graph is the vertical asymptote and the horizontal asymptote. So let's start with the vertical asymptote. We know that vertical goes like this and horizontal like this. So for the vertical asymptote, we have a -2. So we plotted in the x1, -2. And mark our beautiful line. Yeah. And for the horizontal asymptote, we have it in 1, and it goes like this. So we graph it in the y and plot our beautiful line. So now we have to plot the x-intercept and y-intercept. So for the x-intercept, we have a -3. So we plot it in the -3 point over the x line. And for y-intercept, we have 3 halves. So we plot it in the y-intercept in the 0.5. And now we have to find like where does the line goes. So we can take a number, for example, let's take -4. So you substitute x for -4. So -4 plus 3 will give you -1. -4 plus 2, -2. So this point will be in the 0.5. If you have a negative over a negative, it becomes positive. So our point will be here. So we can understand in this side that the line will go close to the horizontal asymptote, but never touching 0. It passes through the points that we found earlier with -4, touches the -3 intercept, and goes down, getting closer to 0, but never touching it. And now let's find this side. Let's take a point, for example, 3. 3 plus 2 over, 3 plus 3 over 3 plus 2. And this gives us 6 over 5. So that point will be 1, 2, 3. Here closer. Oh, yeah. So we can find that our line will go closer to the vertical asymptote but never touching it, passes through the 3 half points in y, passes through the 6/5 and goes closer to 0 but never touching it. And now let's plot our hole. We know that our hole is in 2,5 fourths. So we search the 2 in x and 5/4 in y. So here will be our hole.
Alright, so now it's time for the final 2 parts of this equation. Now we need to find the domain and the range. The domain, a quick refresher here, are all the values of x, while the range are all the values of y. Now, over here, the equation will go on forever to the infinite side of the negative. So the first part to finding the domain is writing down -infinite. So now that it stops here at the vertical asymptote of 2, meaning that it will never touch it here, we also graph that, or we also write that down. And since we can never truly achieve -infinite or 2 in this situation, you write them with rounded parentheses, which means that these values are not included in the domain, just everything in between. And now we graph this part, which, like the previous part, never touches -2. However, here we have something interesting. That is the hole, meaning that the domain does not reach there either. Okay. So with that in mind, we also plot 2, which is the x value for the hole. And now we need to add one more part to the domain, because after the hole, there's still this part of the equation which also contributes to the domain. Again, we're writing this in open parentheses because no, in rounded parentheses, because 2 is not included in the value of the domain. And now, since all of these are part of the domain, however, they're like, let's say, broken up into pieces, you could say that we unite them using this way of writing them with the union, meaning that all of these are together, and all of this together is your domain. And now the final step is to find the range, all the values of y, and for that you only take into consideration the horizontal asymptote, which eliminates 1. So again, this will go to negative infinite and will never touch 1. So but you also need to write 1 in the rounded parentheses or the rounded bracket to show that it's all the values between 1 and negative infinite. And same over here. It will never touch 1. So it's all the real values between 1 and infinite, written as such. And there. Now you have the domain and the range of this equation.